Hello everybody, grade 11 and grade 12. We are looking at our 7th lesson on equations, and this 7th lesson we're looking at nature of roots. Nature means the behavior of something. So from that word, nature. But the question is, what are roots? So when we say nature of roots, let's break it down. Almost an English class this morning. The word nature would mean the behavior. Now, what are roots? We're going to use a principal definition for roots. Roots are the x values. All right? Roots are the x values or solutions of point of intersection. This has a lot to do with graphs of two or more functions or equations. Point of intersection, and we are focusing on the x values. Hi, Madekwi, good morning to you too. X values or solutions of point of intersection. Please focus on the fact that I said x values. We're going to break this down quickly. Consider f of x equals to ax squared plus bx plus c. Consider that. All right? From grade 10, we know that f of x simply means y. All right? And we have this ax squared plus bx plus c. We are not new to that. Okay. If f of x equals to 0, that is ax squared plus bx plus c equals to 0, then the roots of this equation are, you see, I didn't say root, I said roots, which means we're looking for the x values. X will be equal to minus b plus or minus square root of b squared minus 4ac over 2a. The roots, take note of that word s, the roots. And when I say roots, I'm talking about x values. And you would see there are two of them, plus or minus. And I'm sure you all remember how we got that equation. We dealt with that, how to get that quadratic equation. So we're saying, that is, let's just rewrite this, ax squared plus bx plus c equals to 0. X is equal to minus b plus square root of b squared minus 4ac over 2a, or x equals to minus b minus square root of b squared minus 4ac over 2a. If we split it, it becomes plus or minus. And we can call this x1 and call this x2. And just to quickly put a graph for us, I'm not going to really deal with much of functions today. x1, x2, and this is ax squared plus bx plus c. And this one here, y is equal to 0. This is why we said these are points of intersection. Point of intersection. And these are called what? Roots. Because they are the x values of the point of intersection of two graphs. We go gradually. Nature of roots. how will these x values behave? Let's write that quickly. All right, I'm sure we are done, ready to move together. So don't lose my explanation. I want to take it step by step. Don't lose my explanation. Okay, so we have the points of, let's put S there, points of intersection. And those are called the roots. The x values are called the roots. Now, what are the types of roots that we have? I'm going to try to use, okay, but before I go there, what determines the type of root? Now, the factor that determines the nature of the x values of the point of intersection, which is what we call roots, is what lies under the square root. I want us to quickly look at this together. This is called the discriminant. With a symbol delta. So we're saying x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And this is what we're looking at. That is, x can be written as minus b plus or minus square root of delta over 2a, where delta, which is our discriminant, is b squared minus 4ac. How this guy behaves, and I'll show you what I mean. How it behaves will give us the value of x. The value of delta, let's just write this quickly, determines the values of x. The value of that triangle thing called delta, the discriminant. So let's put it so I can, once I use the word delta, the value of that delta would determine the value of x. I'm going to quickly show you quickly the possible values and the meaning. Possible values of delta and the impact on x. The possible values of delta and the impact on x, and let's say the meaning. what are the possible values of delta? We'll start with about 5 of them. When delta is equal to 0, when delta, remember we have both x1 and x2. When delta is equal to 0, it simply means that the square root of delta, all right, which means the square root of delta will be the square root of 0, and that is 0. X1 will therefore be equal to minus b over 2a. X2 will also, okay, let me put it in one line. X1 will be equal to x2, which is minus b over 2a. I want us to explore what that means, but I don't know if you see what I'm trying to say. That if my delta is 0, just a rough work, minus b plus or minus square root of 0 over 2a. What's the square root of 0? It's 0. So I'm going to have that. So minus b plus 0 over 2a minus b minus 0. Do you see that? That both of them would give me minus b over 2a. That's what we're trying to say. We'll still look at it. So it means my x1 is equal to x2, and that gives me something. x1 and x2 are my roots. It means I have what? Equal. Or let me say real. All right? These are real values. Real and equal roots. Don't worry, we're going to draw a few things to help us see. Just want to quickly set that foundation. When we say equal roots, x1 will be equal to x2. That's the first one. If my delta is less than 0, what will the square root of delta be of a negative number? This is undefined. We cannot find the square root of a negative number. So we are going to say x1 and x2 do not exist. And we call this non-real roots. I'm going to repeat this, but I just want to give you the 3 basic ones. Greater than 0. We are going to have 2 different positive values. x1 will not be equal to x2, but they exist. These are called real and unequal roots. So these are the basic 3, but I'm going to draw a graph, a table right now, or a flow chart that will expand this into 5. So please walk with me. Possible values. These are possible values, but we're going to go a bit in depth into this. Possible values. And we'll look at an equation to really see what this means. I want us to see what this really means. So I'm going to start from, before I draw my entire table, I think let's go into each of them one by one. Because I wanted to see what real roots are. I wanted to see what non-real roots are. Then we put all of them under one umbrella. It's going to make a lot of sense. let's get into the real work now. So we might repeat a lot of these notes again and extend it. Are we ready? Because I want you to understand what we're talking about, not just writing notes. I want it to make sense to you. I want it to make sense to you. Okay, so let's do it like this. Let's do it like this. All right. Roots. Roots. Roots can either be real or non-real. Roots can either be real or non-real. When we say real, we're talking about the value of x exists. Non-real, let's quickly break this down for us. Non-real, the value of x does not exist. And this will give us what we call no solution. I want us to quickly explore this. So let's look at real roots. Real roots. Let's take it step by step. When I'm done, I'm going to give you one page that covers everything, but I want to break it down first. Real roots. And I'm going to repeat a lot. Roots are x values. So x equals to minus b plus or minus square root of b squared minus 4ac over 2a. For this to exist, b squared minus 4ac must be greater than or equal to 0. Okay, I'll pause a little there. For that to exist, b squared minus 4ac must be greater than or equal to 0. B squared minus 4ac must be greater than, if not greater than, it must at least be equal to 0. And we're going to look at an example. And we can tell if a solution can be possible or not just by looking at the equation. We can tell if we are going to have a solution or not. Are we ready? Okay, let's look at. I'm going to write two equations and I want us to predict if they are real. Number one, x squared plus 10x plus 25. Let's look at that, because I want us to see what it means. Can we solve this? That's the question. Is this solvable? Let's find the discriminant, b squared minus 4ac. Let's find it. What will it be? 10 squared minus 4. What will this give us? It's a 0. It's a 0. the discriminant is equal to 0, the roots are, number one, real. It means we can solve it. It has an answer. And number two, the roots are equal. And we're going to try to solve it. Let's solve. The roots are real, which means there's an answer if we punch it in a calculator. And number two, we would notice our x values. So let's solve. Solve x squared plus 10x plus 25 equals to 0. Minus b plus or minus square root of b squared minus 4ac over 2a. Because of space, I want to put everything here. Guys, we know all of this, right? This we did long ago, lesson 2 or so. We're just substituting. Over 2 multiplied by 1. Remember, we are going to have two answers. I want us to see the nature of these answers. Are these answers real? Are we going to get the value from our calculator? And if we get answers, what will the answers look like? That is what, remember. So if the answers, if we get answers, they are real. But let's compare x1 and x2. I know you're writing, so I'm going to punch it in the calculator for you. Negative 10 plus square root of, please remember to use brackets, minus 4ac over 2 multiplied by 1. Oh, my first answer is negative 5. Okay, I'm going to try to change it. You know the drill. Oh, my second answer is also negative 5. The fact that I am getting answers means that they are real. And my answers are equal. It means they are equal roots. Please talk to me if this makes sense to you. So you can see we predicted it already. That if delta is equal to 0, my answers would be real. That is, they exist. And number two, x1 would be equal to x2. Real roots. Please talk to me. So this is the first one we're looking at. Roots are real and equal. Please box this thing for me. Box this information. Box that information. We're going to put all of this information together. So number one, information. Roots can be real. And not just real, they can be equal. And the condition for them to be equal is that b squared minus 4ac should be equal to 0. May I see if there's anyone who is lost? Number one. We're done with number one. If you are okay, please give me a thumbs up. Quite a number of people in class again this morning. Thank you for waking up. I need to see all thumbs up if you are okay, as a show that I can continue and that you do understand. Yes, Madekwi? Good morning.
Hello.
Hi.
Hello.
Good, and yourself?
I'm good. When you were solving for delta, when you said 10 squared minus 4 multiplied by 1 multiplied by 5, not give you 0 as not give you minus 4.
What, did you press it like that on your calculator?
No. 10 squared is not 200, right?
Yes.
Whereas minus 4 multiplied by 1 is minus 4.
What about the
4 multiplied by 35 is 100.
Yeah.
Then I already gave me minus 4 instead of 0.
Oh, wait. You actually gave me the whole answer. What did you say 10 squared? 10 squared is what again?
100.
100. Okay. What is minus 4 times 1?
Minus 4.
Times 25?
It's minus 100.
So what is 100 minus 100?
Ooh! Oh, I did 1 by 1. Minus 4 multiplied by minus 1 by 1. Okay, so.
Are you good now?
Yeah, I'm good, thank you.
Okay, all right. Okay, guys, number 1 is done when the discriminant is equal to 0. These are the things you must remember. All right. So this is number 1. Maybe we should just put a let's say real and equal. Real and equal. Number 1. Let's go for number 2. Let's go for number 2. Remember, we're looking at the solution existing. Number 2. Real and unequal. Oh, by the way, let me squeeze something here that I needed to squeeze in for me here. Oh, sorry, I'm going to questions already. Let's squeeze in a graph here quickly. What will this look like? Just squeeze in that graph for me. This is functions. The graph will only touch once. The graph touches. Touches and turns. Touches and turns at the same point. One point of intersection. Please put that down for me. 1 point of intersection. It could be on the left hand side, it could be on the right hand side, it doesn't matter. But we are looking at just 1 point. One point, equal roots. The graph only touches once because my x1 value is equal to my x2 value. Okay, guys, can we move on? These are still under real roots. Number 2, we'll still put all of this together. When do I have this? Here, the discriminant must be greater than 0. If my discriminant is greater than 0, let's look at it together quickly. Example. Let's solve this. 2x squared minus 5x minus 3. What is our discriminant? B squared minus 4ac. My b is negative 5. Please bracket 4 and negative 3. Let's see this. What will this be? If we put all of this, please, again, I want to show you something. If I don't put it in bracket, what will happen? Will my answer be different? Especially that minus 5. Look at my answer. It's giving me negative 1. But if I put it in bracket, will it be different? Absolutely yes. Let's check. Look at it, 49. Do you see? Very, very different. Very, very different. Okay. Let's see. It means yes, since this is greater than 0, the roots are 1. They are going to be real. That is, they exist. We can solve it. Let's try to see first, before we write the second point. Let's solve. Solve 2x squared minus 5x minus 3. Remember, I cannot solve if it's not equal to 0. X would be minus b plus or minus. Don't be tired of writing this, especially grade 11s. We won't be tired until we know this. Minus 5. I didn't want this to give me a 49. I want something different though. Okay, but it's fine. It is fine. Minus 4. What is my A? 2 over 2 times 2. I wanted to punch this in a calculator and give me answers. My deck has given me 3, but I think we should have 2 answers. Using the positive, we have a 3. Can somebody also assist? Use the negative. Come on, guys. We have so many people in class. I'm only having one person responding. That's not how we have a class, people. That's not how we have a class. What if that person made a mistake? We are all going to flow with that mistake. Please, can I have more people checking? Get a calculator, please. If that person makes a mistake, then we all flow with that mistake. No, that's wrong. Come quickly. We have Zianda, we have Hope, we have Atlehan, we have Ken, we have Yolo. Too many people. I cannot have one person responding. For negative, it's negative 1 over 2. Confirmed? Thank you, Hope. For positive, it's 3. Thank you, Hope. Please, it is important that we have multiple answers, people verifying. It also helps you to increase your own speed. In an exam, no one is going to be there to help you with those answers. All right, so we have negative half. All right, what do you notice? Do you notice our answers are not the same? Hence, we mean they are real. And number two, they are unequal. They are real. Yes, my answers exist. They are real. But they are unequal. So, my graph, what will my graph look like in such a case? I'll have two different x1 and x2 values. x1, x2. These are real and unequal root. And for this to happen, discriminant must be greater than 0. So we have two things for real roots. We have two things already. For real roots, our discriminant must either be greater than 0 or equal to 0. For roots to be real, our discriminant, b squared minus 4ac. Other things would come from there. Other things will come from there. Can I summarize just what we've done quickly? For real roots, just to summarize quickly. For real roots, you understand what I mean by real now? The answers do exist. For real roots, we came across that we have two things. Is either our roots are equal, discriminant is equal to 0, or unequal, discriminant is greater than 0. But combined, for real roots, it means the discriminant must be greater than or equal to 0. That's our first conclusion for the day. For the root to be real, the discriminant must be greater than or equal to 0. Non-real roots. Non-real roots. Non-real roots. Are we ready for that? So it's either our roots are real or non-real. This means we have no x values. That is, the solution does not exist. That is, it cannot be solved. For this to happen, the discriminant must be less than 0. So if delta is less than 0, that is negative, the square root of a negative is undefined. Hence, x has no solution. Let's write that quickly. Let's write that quickly, and we're going to look at an example. We are almost done with nature of roots. I'm just trying to take it very slowly. X squared minus x plus 6. Let's find our discriminant here. B squared minus 4ac. What do we have? Minus 1 squared minus 4. Okay. What you notice here, if you do this, I think this would give us a negative. 1 minus 24. Ah, beautiful. Negative 23. Okay. Okay, let's solve. Let's try to solve. Solve x squared. You would even see that we cannot even find factors that would work. Minus b plus or minus square root of b squared minus 4ac over 2a. Minus 1 squared minus 4. All right, I'm going to wait for you to put this in a calculator and get me answers. We're going to add 2 more under real roots, but quickly, I would like answers from here. Then we go into activities. I think we have close to, you know how we do it, about 15 activities to look at. We'll look at activities for about 1 hour. Please plug it well into your calculator when solving. Anybody that has finished writing and plug it in the calculator, please share your answers with me. Zianda says maths error. Maths error for both of them. Ken says the same. Are you guys joking? How come we don't have answers? What do you guys mean? I don't trust you guys anymore. We've done this for 6 lessons and you're telling me there's no answer? Negative, open bracket, negative 1, plus square root of. I hope you guys closed your brackets. Negative 1 squared minus 4. My A is 1 and my C is 6 over 2 multiplied by 1. Oops, math error. Do you know why we're getting math error? The reason we're getting math error is because of this guy. This guy is giving us, this guy alone is giving us a negative 23. And we cannot find the square root of a negative number. Can't. So, we have no solution. It means that the roots do not exist. They are non-real. If I were to sketch this graph for you, look at what it would look like. All right, my A is, so it would look like this. Non-real. That's what it would look like. It's not touching the x-axis. It is not touching the x-axis. I don't know if it makes sense to you. That roots, we now see that everything that is happening is controlled by what's underneath the square root. If it's a 0, we have the same answer. If it is positive, we have two different answers. If it is negative, then we have no answer at all. Okay, so we have real roots and we have non-real root. Like I said, I'm going to put all of this in one single page for you. All right, so all this summary will be put together. We can just put this one here. Delta is less than 0. Okay, now other types of real roots, and then we will be done. Or let me just do other types of, let me do everything here. Roots. Please hold on, don't write, so that you will see how to put your note. I'm going to look at other types of roots just now. Roots. Okay. Roots are controlled by your discriminant. All right? Controlled by discriminant. X. Don't write. X is equal to minus b plus or minus square root of your discriminant over 2a. All right? Now, we said roots can either be real or non-real. Roots can either be real or non-real. And what is the condition for them to be real? The discriminant must be greater than or equal to 0. I think that's why I said you should hold on. I know what this graph should, what this thing I want to do should look like, but you don't. So I want you to be able to manage your book very well. Okay. All right. Roots would either be, I think I want to do something, draw it with a different shape. Real, okay, or non-real. Roots would either be real or non-real. Yeah. So that I can have enough space. So that's why I said don't write. I want you to just listen to me. I'll give you time to write. I want to put everything that we've said together and add one or two. Okay. Roots would either be real or non-real. And we saw what it means to be real. Then we'll start picking information from this flow chart. Beautiful. Oh, exactly. I think I'm having it very, very good. Roots are either real or non-real. Okay. And for it to be non-real, what is the condition for it to be non-real? The discriminant must be less than 0. Oh, by the way, let me add something to this. I want this graph to have everything that we've discussed. What is my discriminant? B squared minus 4ac. Now, when we look at real roots can be, let's use a green one for my arrows. Real roots can be divided into so many. We have 5 that I want to quickly draw for you. 5 of them. I'm done with non-real root, right? I'm just going to draw. Let me not forget to draw a graph here. Let's use white. Sorry, I just like colors. Like I said, don't draw anything yet so that you'll be able to see how to manage. That's my real root. Or non-real root, rather. It's not touching. Okay. The first one under this will be equal roots. For that to happen, just the word equal, my discriminant must be equal to 0. It means x1 will be equal to x2. And what will my graph look like? Let's use a white. 1 point of intersection. Graph is turning there. 1 point. Okay, I gave you notes there already. x1 is the same as x2. That's the first one. Number 2. Unequal. They all fall under real roots. Unequal roots. The discriminant must be greater than 0. x1 is not having the same value as x2. What will my graph look like? My graph would look like that. They are real. Oh no. x1, x2. Now the other ones that I didn't tell you is now this, number 3. Rational roots. That is, x can be written as a fraction. X can be written as a fraction. We'll look at that just now again. For this to happen, my discriminant must be a perfect square. That is, once I get this, I can write it as a squared. We did one example earlier on, and I'll show you. If that happens, yes, my graphs are real, my roots are real, but it doesn't mean that I'll have 1, I will have 2, but these values can be written as x1, but it can be written as fractions. I'll show you that example that we did. And the last one, irrational roots. X is a decimal, not a fraction. It cannot be written as a fraction. This discriminant, not a perfect square. Not a perfect square. I'll have the same graph, but as decimals. My x values will be decimals. They are real, but decimals. Here, these are fractions. X can be written as a fraction. X can be, so maybe x1 can be a over b. Oh, don't let me use a and b because we have that in the equation. K over m, and x2 maybe d over q, whatever it is, just showing that it's a fraction. Okay, roots. Guys, this is everything about nature of roots, including the graphs. Somebody take a picture for us, and I'll give you just a minute to write as quickly as possible. And this is everything. Yes, for example, we did that one of 49, if you remember. Now we can answer questions. This is the end. We just need to apply this now and see how examiners are going to test us on this. Please write quickly. Please master all the conditions. Let me put all the conditions in yellow boxes. For equal roots, we have that. On equal roots, we have that. For rational, this must be a perfect square. For irrational, this is not a perfect square. So we have 6 things that you must remember. Real, non-real, real and equal, real and unequal, real and rational, real and irrational roots. All right, thanks, Yanda, and thank you, Ken. They have shared the pictures on the grade 11 group. I don't know, maybe there's no grade 12 learner in class, or they choose not to share with others, but I will leave that to them. I want us to quickly predict. I'm going to write just a few equations on the board. I want us to predict, will it be real, non-real, then go into questions. Will it be real, non-real, rational, or irrational, and then we check. Okay. Will it be real? Will it be rational? Can we write it as fractions? Can we not write it as fractions? And then we will check together what the answers will be. Okay, are we ready? Are we ready? So just to make sure that we are okay and we understand before we start solving, we are going to predict and confirm. The nature of roots. I'll show you what I mean. I'll do the first one. Number one. Let's look at this one. X squared minus 3x minus 40 equals to 0. We're not solving for now. When we say confirm, we solve to confirm, but we want to predict first. Let's look at it. What is b squared minus 4ac? My discriminant. We're going to use that to confirm. What is our b? Negative 3 squared minus 4. What is a? A is 1 and c is negative 40. Okay? Anybody giving us an answer here? 196, I think. So that's 9 plus 160. Yeah. Oh, 169. Sorry. 169. Okay. What can you tell me about this number? Look at 169. What can you tell me? Let's observe 169. Number one, that 169 is greater than 0, which means my roots are real. And number two, they are unequal. However, that 169, do you notice that's 13 squared? It's a perfect square. So what does that tell us? Because it's a perfect square, my roots are what? Real, unequal, and rational. Rational means I can write them as a fraction. Can we solve? Let's confirm if this is true. Okay, so we have predicted that our roots are real, our roots are unequal, which means we have two different answers, and our answers can be written as fractions. Okay, I think, do we really need that whole equation? I think we can solve this quickly. It's the same thing. X minus 8 plus 5. So x is equal to 8. Oh, beautiful. Are they real? Yes. Are they equal? No. Can they be written as fractions? Yes. 8 over 1. Check. They are real, they are unequal, and they are rational. I don't know if this makes sense to you. They are real, they are unequal, and they are rational. Remember, I could also solve by saying x equals to minus b plus or minus squared of b squared minus 4ac over 2a. My answer will still be that. Let me know if this makes sense. We predicted and we are correct by looking at our discriminant. May I please hear from you if you are okay with this? That looking at my discriminant 169 can be written as 13 squared, which means because it's greater than 0, my roots are real, my roots are unequal, and my roots are rational. Simply because it is a perfect square. Can I move to example 2? And then we start looking at questions. Example 2. We predict again. And I want you to predict this one for me. 2x squared minus 3x minus 7 equals to 0. Okay, let's do this. B squared minus 4ac minus 3 squared. Okay, I want an answer from you, and then we predict from that answer, just to make sure that you guys are not just copying, and then to make sure everyone is following. Yes, Lusanda?
Morning, sir.
Good morning, Lusanda.
Sir, today you didn't send the link in the group, so may you please send everything that was messed up in the group, sir.
What do you mean, Lusanda? I sent it.
Sir, apparently you sent it in the grade 11 group, not in the grade 12, sir.
Really?
Yes, sir. Yes, sir.
Oh, sorry, guys. Maybe I was dreaming. Oh, okay, I see now. I'm so sorry. Okay, we'll just share the lesson directly. All right. So sorry about that. Okay. Anybody giving me an answer here? What's our answer? Lusanda, are you giving me 47?
Yes, sir. Got 47.
Okay. Is there anybody else confirming that? Guys, remember what I said. I need participation.
Yes,
Ntokozo, thank you very much. Please, let the class be active, otherwise people start falling asleep. Okay, if it's 47, what can you tell me? Sir, why did you put A minus before the b. Oh, sorry. Thank you, Ken. All right. Is this still 47? I put a negative there. It wasn't supposed to be there. So it's going to be 9.
65, sir.
65. Okay. Sorry, I made a mistake there. 65. Okay, thank you. Now, based on this 65, what can you tell me? Let's predict. Quickly, let's predict. I need those predictions to come through. Sorry about the negative there, which confused us in getting 47. Thank you, Ken, for picking that up. All right, guys, I need answers. My discriminant is 65. What can you tell me? Quickly, before we start solving. Predict the answers. Prediction. Anybody? Roots are real. Do we agree? Madua says it's a real number, but it's not a perfect square. Okay, so it means roots are real. Why are they real? They are real because the discriminant is greater than 0. Number 2, are they equal or unequal? Talk to me. Before we solve, we're going to solve now to find out. Am I going to have x1 equals to x2 or x1 different from x2? That's what I mean by equal and unequal. Come quickly. If you have been following now.
Sir?
Yes, Ntokozo?
Sir, I don't understand what you're saying when you say x1 is equals to x2. Something you just recently said.
Did you just join in Ntokozo? Or you've been in class from the beginning?
So we just joined because the link was only joined now.
Oh, sent now. Oh, my bad. All right, because I'll help you. When we say x1 is equal to x2, it means that the roots are equal. Let me take you back quickly and show you something. I'm so sorry about that. But please, you need to quickly watch this lesson like immediately. Okay, so this is what remains. When we say real root, it means when we solve. Yes, for example, when we solve this particular, we are getting x1 as -5, x2 also as -5. So we say they are equal because my answers are equal. And that can only be possible if you look at this table that we have. All right. So x1 is equal to x2. That can only be possible if our discriminant is equal to 0. If our discriminant is greater than 0, for example, like the 65, x1 will not be the same as x2. They will be unequal, yet they are real.
Oh, okay, sir.
If it's a perfect square, we're going to have real and rational. That means we can write them as fractions. If it is not a perfect square, they are real, but they are going to be decimals, not a fraction. So we are basically studying this 65. What can we say about 65? It is greater than 0, so the roots are real. It is not equal to 0, so my answers should be what? Unequal. And number 3, they should be irrational. Why? 65 is not a perfect square. Let's prove it. 2x squared minus 3x minus 7. Look, I can't even open brackets right now. I have to just minus b, all right, plus or minus square root of b squared minus 4ac over 2a minus 3 plus or minus 3 squared minus 4 and negative 7. Okay, I'm grabbing a calculator to prove that we're going to have two different answers. Negative 3 plus square root of negative 3 squared minus 4. My a is 2 and my c is negative 7 over 2 times 2. Let's see our answers. 2 point. Do you see it's not giving us a fraction? It's irrational number. Okay, 2,77. All right, 2 decimal places. Let's change it to a negative, maybe the other one. It's irrational. Oh, negative 1,27. Okay, negative 1,27. And what was the first one again? 2,77. Check. It's perfect. They are real, they're not equal, and we don't have them as decimals, as fractions. You cannot write these numbers as fractions, so they are irrational. I hope it's making sense, guys. That looking at your discriminant, you can predict the answer. Please let me know if it makes sense, especially for those of you that just joined in now. You need to go back, check the notes. Okay, let's do one more, then we go into questions now. Let's see one more. Number 3. Number 3, let's see something. Were you able to solve this, guys? Were you able to predict? Can you list your answers for me? Are they real, rational? Quickly list before I do it. Yes, answers? Real roots, unequal, and rational. Are you sure they are rational? Okay, what's our discriminant? B squared minus 4ac, 10 squared minus 4, 1 and negative 21. What are you getting here? That's 100 minus 84. 16, I think. Because I'm seeing two different answers. Somebody's giving me rational, somebody's giving me irrational. 184. Yeah. 184. So the question is this a perfect number, perfect square? How do you check if it's a perfect square? You just say 184. Sorry, square root of 184. So it's not a perfect square. So you can see discriminant, yes, is greater than 0, which tells me that my root should be real. And what? Since it's greater than 0, should be real and unequal. But it is not a perfect square. All right? Not a perfect square. Therefore, it should be what? Irrational. Somebody gave me that they are rational. No, they should be irrational. Can we confirm again? Who gave? Yeah, it's irrational. Okay, Lucinda. Okay, guys, when you solve, do you want to give me your answers? Let's look at real exam questions now. Minus B. Now that it's like we understand. Now let's see how examiners are going to ask us. Minus B. 10 squared minus 4 AC over 2 times 1. Quickly. Do that for me, then I want to give you one more. I want to give you one more. Somebody please give me answers rounded off to 2 decimal places for the first one, and then we check with the second one quickly. Okay, guys. Positive says help. 1,78 or I got positive for plus. I got okay. So do we agree with the answers? 1,78 and negative 11,78. Is that an agreement? So we carry on. 1,78 or x equals to negative 11,78. So guys, do you see that yes, they are real, they are not equal, and they are irrational. Irrational means we write them as decimals, not fractions. Are we okay? And number 4, what did you get from me quickly? What is my discriminant? B squared minus 4ac negative 5 squared minus 4, 2, and 3. What would that be? What would that be? What's our discriminant here? 6, 4, 24, 25. So this is 1. Now you would notice that this one can actually be written as 1 squared. So what are we expecting? We are expecting it to be real. We are expecting it to be what? Unequal. And we are expecting it to be, because it's a perfect square, we are expecting it to be rational, which means my answers can be written as a fraction. And is that true? If we solve this, somebody solving that for us, let's check quickly. What is x1 and what is x2? I think somebody's giving me answers. Lusanda. No, somebody was giving me answers. Wait, Decan, where are you getting negative 49 from? Decan, do you want to quickly unmute yourself? I don't want to fall behind. Quickly. Lusanda gave me 1,5 or 1. Lusanda, what answer is this? Is this the answer for number 4?
Yes, sir.
So 1,5 or 1. And what is 1,5? 3 over 2.
It's 3 over 2.
Alright, so do you see they are real, they are not the same, and can be written as fraction. That negative 49, can we quickly sort it out? Very fast, very fast. We are done with all my explanations. It is now for us to look at questions. Yes, Ntokozo?
So, I think they can didn't put the negative 5 in brackets. Just put the same mistake.
Yeah, and that's the mistake I said we should not be making, right? So let's write nicely and get it done. Okay. So guys, all the notes, did it make sense when we put in numbers now, right? You can see that everything I've taught you now comes back to the page. So this page is very, very important. You need to master this page. This page has everything that we need. Roots are either real or non-real. What's underneath the square root is what is important. If it is equal to 0, equal root. Greater than 0, unequal. As a perfect square, rational. If it's not a perfect square, irrational. If it is less than 0, we talk about non-real. Please know all of these conditions. How will examiners ask grade 12? I don't know if this is on your group. Somebody just take it. If somebody in grade 12, just quickly take this. So I'm just having a lot of calls coming in, hence my response was a bit distracted. So many calls coming in. People are already calling for registration and all of that. And I'm the only one in the office today. All right, grade 12, I'm sure you've taken a picture of that. Okay, we won't do much activities like I wanted us to do as usual, but we will see how to catch up. Okay, look at this. Number 1, for which values of k? Now, please, examiner is saying find the values of k. For which values of k, number 1, will that have non-real root? What is the condition? And guys, you cannot do it until it is standard form. Kx squared minus 6x minus 3. For non-real roots, you know what the condition is. For non-real roots, the discriminant must be less than. That's the information that you need. The discriminant must be less than 0. Okay, so I'll start with that. B squared minus 4ac should be less than 0. What is my b? Negative 6 minus 4 What is my A? K. And what is my C? Negative 3 less than 0. Negative, negative, positive. 24 times 3 is 12. 12K. This is what? 36. Plus less than 0. 12K is less than negative. Guys, I am not changing my inequality. I only change when I divide by a negative. So K should be less than what? Negative 36 over 12. When K is less than negative 3. I don't know if number 1 makes sense to us. Does number 1 make sense to us? So you must know the condition for which values. That means I need to solve, guys. For which values. I want you to take note. We're going to see 2 different types of questions. For which values. So I'm solving. Okay. Again here, number 2, determine the value of K. But what are we looking for? Given the equation that has what? Equal roots. So those are the things I'm looking for. Oh, 4x squared plus kx plus 1. For equal roots, what should happen? Discriminant must be equal to what? 0. B squared minus 4ac. What is our B? K squared minus 4 times 4 times 1 equals to 0. K squared minus 16. Oh, K squared equals to 16. What is K? We are solving. We've gone through this. K has to be either positive or negative 4. We've done that a lot, that when we are solving and there's a square root that we are introducing, it has to be plus or minus because of difference of 2 squares. Somebody who doesn't understand the plus or minus, check this. K squared minus 4 squared. That's what that means. K minus 4, K plus 4. So it's either K equals to 4 or K equals to negative 4. Oh, they said where K is less than, now we have to conclude where K is less than 0, therefore K equals to negative 4 because of the condition. That condition where K is less than 0, it means K has to be negative 4. Are we okay with the first 2? So it's a matter of putting the notes at the back of your mind and going through. Okay, trying to run. Somebody take a screenshot of this, send to the group. Let's see, grade 11, 12 quickly. Let's see if we can do 6 questions more. Okay, look at this one. For which values of x will that be real? We want these to be real. For which values of x will x equals to all of this? Remember, for something to be real, whatever is under the square root. But this one is quite tricky because there are x on both sides. But for something to be real, basically, number 3, for something to be real, whatever is underneath the square root must be greater than or equal to 0. That's what we're saying. it must be great. Whatever is underneath the square root must be greater than, because we cannot find the square root of, we cannot find the square root of a negative number, right? So what do we do here with this one? What do we do with this one? Okay. Now, because we have x on both sides of the equation, that's very tricky. That is very tricky. You see, I've got x here. For which values of x will... that's very tricky. Let's try to expand first. I want to see something. This is looking... I'll test something here quickly. 3 minus x plus 5. Let's expand. I want to see something, because I have x on both sides. All right. If I square both sides, x squared would be equal to 3 times x is 3x plus 15 minus x squared minus 5x. Just want to check something quickly. All right. 20. If I bring everything there, that would be 2x squared. 3x minus 5x would be negative 2 plus 2x. I'm already bringing everything over, minus 15. For it to be real, no, okay, this would not give us an answer. This would not give us an answer. I'll tell you why. Because once I say b squared minus 4ac, then, okay. So for it to be real, what? Yes. Somebody's raising their hand or something?
Sir?
Yes.
I didn't square the, well, I think you cancelled, because the x that's there, I didn't square it, I just did it the way you're doing it now.
Yeah, I was just checking out something there. All right. Okay, so this takes us back to our inequality. Guys, remember, we have a problem. And what's our problem? This guy is not in standard form. So we have to change it by swapping it. X minus 3. And once I do that, what happens? My inequality sign changes. We did all of this when we're dealing with inequalities. So come quickly, let's run. Smaller number on the left and bigger number on the right. Plus, minus, plus, less than 0. X should be between or equal to negative 5 or 3. Are we okay there, everybody? Number 4. All right, look at this one. Show. Do you see this one? Show. It's different from for which values. Every time I see for which values, I have to solve. So when I see for which values, I'm solving. Yes, talk to me.
Sorry, sir.
Yes.
Sir, can I please ask, what happens if, would I be wrong if I multiply to the bracket and then compute it into standard form, then simplify?
It's too long. Do you get it, Lucan? You came back to this answer, right? Yeah, too long. Too long. All right, look at this one. Show that. We're not solving now. Show that. Okay, how do we tackle this one? The square root of a squared minus b squared. Okay. is non-real. That this is if for b greater than a. Oh, I see something here. Do you notice that this is difference of two squares? So we are left with the square root of a minus b. But they told us b is greater than a. Oh, check. If b is bigger than a, then a minus b would be less than 0. Oh, perfect. If b is bigger than a, for example, b is 5, a is 2. What is 2 minus 5? Negative. Therefore, the square root of a minus b is non-real. Oh, we have shown. Because we have saying a minus if. So the answer is actually here. If b is greater than a, then a minus b would be negative. Therefore, the square root of a negative value is non-real. You see, they ask us to show. They know it's non-real already. You need to show. Are we on the same page? Okay, let's answer maybe two more. Oh, I have so many. For which values of k, you see, for which values, I've got to find k, will 6x squared plus 6x plus 4kx. Oh, interesting. Let me write that down. 6x squared plus 6. They said they want it to be real and equal. Real and equal. What does that tell you? Real means my discriminant must be greater than or equal to 0. Real and equal. The two conditions are met. Real and equal. Okay, sweet. But before I do that, I have to write it in standard form. Since they said to be real and equal, the discriminant, that must be that. B squared minus 4ac. All right, what is our b? My b now is negative 4k, right? The coefficient of x. Minus 4, 6, and 6 greater than 0. 16k squared minus, what is 24 times 6? What would that give us? 140 something. Okay, my brain is not braining. 36. 144. Yeah. 144 greater than or equal to 0. Okay. Now, please be careful with this k squared. Be very, very careful. This is difference of two squares. Because this can be written as 4k squared minus 12 squared. Be very careful. Don't when it comes to inequalities, don't just just say square root plus or minus. You've got to know how to work things out. All right. Now, what will this give us? 4k minus 12. Yes.
What is so just want to find out is the entirety of b not negative 4kx?
No, b is 4k. Remember, ax squared plus bx plus c. 6x squared minus 4kx. Can we compare? Check that. My a is 6. My b is negative 4k. Because b is the coefficient of x. Are we okay there?
Yes, sir. Thank you, sir.
All right, awesome. Okay, so here, guys, what is our... Oh, we could actually divide by 16, right? Actually,
Yes, sir, that's what I did.
okay. What is 144 divided by 16? 3.
9. Yes, sir, 3 will divide.
Sorry?
It is 9, sir, and then when you square it's 3.
Yeah, it gives you 3. Okay. So let's do that to make life simple. So what is this? K squared minus 9. Okay. But there's nothing wrong. We will have still gotten the same answer. We will have gotten the same answer, guys. So don't be deceived. Negative 3 and positive 3. Remember, positive, negative, and we are looking for greater than 0. They are on the right and the left. So K must be less than or equal to negative 3, or K must be greater than or equal to positive 3. All right, are we okay, everybody there? Are we okay, everybody? Okay, let's look at this one. I think we might look at, I'll give you a few questions that you try to do them, and then we mark in our next session. The root of the quadratic equation is given as that. Determine the values of K for which, all right, look at this one. I love this. 6.2. The examiner has already given us, they've actually simplified this. 4 minus 20K over 2. Oh, so what we need to look at, they said to have what? Will have real roots. What we're really focusing on, we don't need the whole equation. All we need is that. That's our discriminant. That is our delta. So for us to have real roots, what did we say? The discriminant must be greater than or equal to 0. So 4, do you see where they were hiding that? Minus 20K, negative 4. Let's divide by negative 20. Your inequality sign changes. Your inequality sign changes. Did that make sense? We don't need the whole what not. Let's try 2 more. Okay, please write. Okay, let's try this one and see. Let's just try this page. Do you want me to do this for you and then give you homework? Okay, let's do this too and then we'll take some homework. Determine the values of k for which that are equal. Okay, 6.3. X into 1 over 2x plus 2. All right, guys, I cannot do anything until I write it as standard form. So let's expand. Half x squared plus 2x plus k squared. Now they want the roots to be equal. Oh, equal roots. Please write the condition. For the roots to be equal, discriminant should be equal to 0. B squared minus 4ac. Now what is our b? Our b is 2 squared minus 4. What is our a? Half. And what is our c? K squared. 4 2k squared. Okay, so what do we have? 2k squared should be equal to 4. I've done the maths there. All right, so what is k? Plus or minus root of 2. That's why the examiner says value or values. Let me know if that makes sense to you. Okay, let's take one more for the day. Given that, calculate the values of p for which the root of the equation are non-real. Okay, x plus 5 squared. I love this one. 5 marks. Let's see. Expand first, guys, always. X squared plus 10x plus 25. Now I'm going to bring everything over, which will be plus p squared minus 1 equals to 0. I have to write it as standard form. But I want the equation, the root to be non-real. Okay, for non-real, what is the condition? My discriminant must be less. You see, once you know your conditions, maths becomes very, very straightforward. What is our b? b is the coefficient of x. 10 squared minus 4. What is a? 1. What is c? C is this whole thing, guys, the constant. 25 plus p squared minus 1. Now we solve. What is this? 100. This is minus. All right, let's simplify it. 25 minus 1 is 24 plus p squared. Now we can simplify. In order to simplify, I don't want to expand, but you can expand if you want, but negative 100. Divide both sides by negative 4. Do you see that will give us 25? Now what is p squared? 1. Therefore, what is p? Plus or minus the square root of 1, which is plus or minus 1. Are we good, everybody? Let me know. Let me know, everybody. You see, once you get the dynamics, you just be flowing like a river of information.
So is C 24 minus p squared? No, 24 plus p squared. Sorry.
Yeah, 24 plus p squared. This is actually less than 0. No, your C is 24 plus p squared. This is it here. Are we good? I don't know why I changed that to equal sign. Okay, let's quickly sort that out. So what is this? 24 plus p squared. If I divide by negative, okay, so what do we have? P squared. I need to bring that back. 24 minus that would be what? Greater than 0. Okay, 24 minus 25. Then we have p plus 1, p minus 1, less than 0. Negative 1 and 1. My answer should be between negative 1 and 1. I don't know, I changed it to equal to 0 somewhere. I think my eyes just went to equal to. Okay, guys, I hope it makes sense. Simplified maths. We just follow the rules. So the notes are always very, very important. The notes are very, very important. Is there anybody with a question? We run out of time now. I was having a lot of distractions here. We run out of time now, but are we okay so far? Any question? Let me see what I had planned. Let me see something. What did I have planned? 6.5, 6.6, 6.7, 6.8.
So question.
Yes, your question? And I had homework.
If I wrote my answer as positive and negative square root of 1 is less than p, is that wrong?
Yes, that's wrong. That's wrong, because your answer must lie between negative 1 and 1. That is wrong. This is the only way to give your answer. Anything from this would be wrong. Is that Ntokozo?
Yes, sir.
Okay. Guys, are we okay? Everybody okay? You see, I had lots of questions to do, but I was quite slow just to be able to carry everybody along, and I was trying to talk to a few parents as well. Okay, let's start taking screenshots quickly. I want screenshots. Screenshot, so this serves as homework. Quickly, screenshots. Let's make it very fast. We have about 6 or 7 screenshots that I need us to take. So I need it to go pa. The first one, is it done? So someone in grade 11 is taking screenshot. Someone in grade 12 also taking screenshot. Please don't wait for people. It doesn't, even if we have 3 people taking it at a time, it's okay. All right, the next one. Okay, we're going for the next one. I'm going for the next one. Grade 12s, you guys are not taking the questions. Okay. And I don't see it coming through the grade 11 ones as well. I don't know if it's my network, but I'm not seeing anything. Guys, how are you going to practice? And I think the last one here, I'm not seeing any. No one is taking. Okay. No one wants to take the questions. Okay. If we are not getting people taking questions, guys, everybody is waiting for the next person to. Right now on the grade 11 group, there's nothing that I have seen concerning homework. Let me check the grade 12. Guys, you must show a bit of responsibility. Oh, grade 12 do have it, and I'm not going to forward from one group to another because we're not taking responsibility. All right, and take this one. I think 4 questions here. All right, so guys, oh, you will send them later. Okay. All right, you were just taking screenshots. You'll send them later. Awesome. Guys, and that is it. Next lesson, we would mark all of this. And then what do we have next? We want to look at exponent. So exponent will be revision. Exponent and study questions, study expressions, that will be revision. So that will take us very, very fast. And we sort all of that out. All right, guys. This is the end of today's lesson. Please make sure, start talking to your parents, join the extra classes. That will really, really assist you in getting better marks in grade 11. Also, remember to follow our social footprints, where there are some lessons I just post on TikTok, short lessons, post on Facebook. Make sure you subscribe to always get information on the lessons. All right, is there anybody with a question? Lusanda, tomorrow should be same time. Okay. Sometimes I just get extra busy, but I'll confirm today. Okay. I will confirm. Just make sure you are on the group. I will confirm today. But otherwise, if there is no question, have a beautiful day, everybody, and see you in the next session. Make sure the homework is all done as well. Bye, guys.